Well, good morning, good afternoon to everyone. Hopefully you're doing well and staying healthy. Today's topic, of course, is going to be management of change on our road to continuous improvement. And hopefully, I hope you're getting out of these webinars as much as we would like. We certainly enjoy doing these and providing as much information and feedback as we can. Always feel free to ask all the questions you want as we're going through these. Certainly we have the chat available, the Q&A that's available for you as well, and we'll be glad to answer any questions that you might have. Management of change is a very important part of your PSM program, and I will say if your program does not have a very robust MOC process, then your PSM program itself is probably lacking and needs some improvement. So we're going to go through some of the things today and talk about what you can do to improve those and look at where most of the gaps that we see in our audits, where those are coming from, and just how bad things can be, just at the same time how good things can be as well. So again, like we do every time, just kind of take you through a process of which we went through already. We really covered all of the PSM elements up through hot work so far, and we've kind of stayed with the order that they're listed in the PSM regulation itself. And today's obviously topic is management of change. So we really have three parts within the MOC regulation itself that I really want to focus on. It's really employees involved in operating a process and maintenance, and contract employees whose job will be affected by a change in the process shall be informed of and trained in the change prior to the startup of the process. And there's the key here, is change prior to the startup, not after or not during, but before the change actually takes effect. Also, L4 is if a change covered by the paragraph results in a change in the PSI or process safety information, such information shall be updated accordingly. Also, the last part is if a change covered by the paragraph results in a change in the operating procedures or practices required in paragraph F. And if you recall from operating procedures, paragraph F is not only your SOPs, but also your safe work practices as well. So making sure that you update safe work practices, whether they're lockout, tagout, confined space, respiratory protection, etc., those would follow under your management of change process as well. So what's the purpose and intent of management of change? And to put it succinctly, it says manage change to prevent catastrophic events. And how do we do that? We do that by considering safety and health effects, by communicating that change to all employees, all affected employees, whether that's contractors, whether that's our own employees, or whether that's a temporary employees that are working in our processes. It's that communication that really helps prevent catastrophic events. It's ensuring that process safety information, or PSI, is maintained. Again, if you were here for my discussions regarding on PHAs and PSI, that's the crux of PSM, or process safety in general, is making sure that that information is correct and up to date. That information is not correct and up to date, your PHA is not going to be as efficient and as effective as it needs to be. Also ensuring that operating procedures and safe work practices are maintained accurate and up to date as well. So here are some of the gaps. Again, for those of you that have not attended some of these webinars, especially in the early days, we talked about the gaps and where these gaps are coming from, and you see a percentage out there. We at PSS and myself have conducted upwards of 250 what we call compliance audits as they relate to OSHA's National Emphasis Program inspections. And out of those inspections, we gather data on where the gaps are, where the issues are that need to be addressed. So when it comes to MOCs, this is what we've got based on those almost 300 compliance audits. 79% of the time, they fail to conduct inappropriate training for an MOC. So in all of those audits that we've done for the most part, one of the findings was an MOC, and that MOC, 79% of the time, finding had to do with appropriate training. And we're going to talk about what is appropriate training here in a little bit. 72% of the time it's failure to update process safety information. And really this number probably should have been higher, but we looked at different aspects of process safety information as we're going through the audit and assigning which element they were more closely related to. And a lot of times they would get related to a different element, such as, for example, if we saw updates to safe work practices that weren't being done, we might attribute that to a safe work practice finding rather than an MOC finding or a PSI finding, for example. And then failure to complete an MOC prior to the actual change being made. 66% of the time when we found issues with MOC, it was because they did the MOC after the fact. So they made the change, it was up and operating, then they wrote the MOC or completed the MOC. The next one was failure to complete an MOC at all. There was absolutely no MOCs generated. That was 37% of the time. So quite often, almost 40% of the time, people are not getting MOCs conducted or completing those when there's a change that is being made. Failure to update operating procedures, about 32% of the time. And then failure to evaluate safety and health effects, 29% of the time. So as you can see, there's a lot of issues when it comes to MOCs, when it comes to compliance with PSM. In general, when it comes to compliance with process safety and the things that we know that can prevent catastrophic events is completing these change reviews and managing your change in your processes. So what are the basic elements of a good, robust management of change system? Well, first, it's a written change control policy and procedure. You need to have one of these in place. Every facility should have a change control policy and procedure in place. That policy and procedure should contain or explain how a change is managed. How do you manage the change from initiation to closeout? What does that process flow look like? Is that process flow well documented so that your employees or contractors can follow that fairly easily? If your program and policy is so difficult to understand and follow, then MOCs will not get done. Again, if you make something easy to do, people will do it. If you make it difficult for them to do, then you can expect people will not follow that the way you'd want. So how is an MOC initiated completed? That should be well defined in your policy and procedures and workflow. Who has responsibility and authority? We can have responsibility, for example, to track an MOC or responsibility to review MOCs. And then you have somebody who has authority to approve all those MOCs. For example, you may have an engineer or ES&H folks in your facility that they're responsible for reviewing certain parts of an MOC. Well, whereas you may have one person or should have one person that has the authority to approve all management or approve all changes. Do you have different approval levels? And a lot of times we recommend that you have different approval levels for something, for example, a quick change. A quick change may be updating a PNID that was redlined, that needs to be just updated, that you found a mistake in it. It's just a quick red line update. You don't need 14 signatures on an MOC to do that, and you could do something called a quick change if it's outlined in your policy and procedure to do so. On more extensive changes, then obviously you need a more formal process. But on the other hand, if your process flow allows certain people to review certain parts of that MOC, certainly that would necessitate you documenting that, first of all, your policy and procedure, and then making sure people understood what their responsibilities and role were in your MOC process. Of course, training all your employees and contractors on that policy and procedure and making sure that they understand what their roles and responsibility are is pretty important. To make sure that they understand what a change is. A lot of times people that we talk to when we do employee interviews during audits don't understand what a change is, what a change that would require a management of change. So making sure that they understand what MOC is, but also making sure that your people know that as well, so that they can help initiate change when they see a change that needs to be managed through your MOC program. And then how are changes validated or reviewed by your PHA teams, making sure that you're documenting all of those MOCs to completeness, so that your PHA team, when it comes to revalidating or redoing your PHA, have a good understanding of all the changes that have occurred in your process since the last PHA had occurred. So what are the basics of a good MOC program? Is one, anyone should be able to initiate or affect change. That doesn't matter if you're an engineer, you're in the facility, you're the plant manager, or some manager. Your operators from the lowest level should be able to initiate and affect change. If we're not doing that, then we're probably missing a lot of the changes that occur in our processes. I remember when I used to work in a production plant, in a chemical plant, one of the things that would occur quite often is maintenance technicians would add this or add that based on an operator's request. When those things got added, a lot of times an MOC was not generated because of those additions, because our people didn't understand what change was, how to manage those changes, and make sure that they understood that they had to follow an MOC program to be able to get that change done. Again, if it was easy for them to initiate that change and complete that change, then we could expect it to get done. And certainly that's a lesson learned for us during that period of time, is to make things easy for everyone to affect a change. It requires commitments on all levels. As I said, not only management, operations, but maintenance people need to be involved, and also contractors need to be included as well. This is a big issue, especially in the ammonia refrigeration industry, where they have contractors come in and maybe do PMs or do maintenance or additions on existing processes. And a lot of times these are done without a management of change being completed. Changes get made in the process, change get made in equipment, et cetera. And none of that has been documented or reviewed through your change management processes. So a typical implementation is an MOC, and most facilities have an MOC form or checklist. Some have computer systems that they can certainly use, and those are good systems to help you, again, make the process of managing change and implementing change simple. So they all should have the basic elements of a good MOC, and the requirements are a description, a purpose, and the technical basis for the change. So what oftentimes we get and see in an MOC is just a description of purpose, but not the true technical basis for the change. It also must have some assigned level of risk. So what is the risk of us installing this or adding this or making this change, and define exactly what that risk is. What is the safety and environmental and health impacts of that change? Also, what is the necessary time period for the change? Is it a permanent change or is it temporary? Obviously, if your policy and procedure does not allow temporary changes, then it's always going to be a permanent. You will not have a necessary time period. It'll always be permanent. And then authorization for the proposed change. Who is allowed to approve that and who must approve that change? A good MOC program or process should also include an interface with your PSSR program. We recommend, and for those of you that were involved in our PSSR webinar, we always recommended that a PSSR be completed on every change that's made. It's just the last opportunity to ensure that all of the changes everything has been updated as required, and everything has been signed off on prior to implementing or adding chemicals to the process. It's always a good idea, as I said earlier, to have a flow chart. Identify the change and evaluate the preliminary risk. And it really helps a person that's stepping through the process of doing a change understand what needs to be done. What is proposed change, review, and approval? Who's going to review it, like I said. Then once that approval has been given for that change, then you go in the development and design of the proposed change. In some cases, that's going to involve a high risk. And if that change has higher risk, then certainly conduct a PHA. If it has low risk, then a simple hazard assessment can be made. But in any case, you must do some type of hazard assessment based on the health and safety effects of the change. Develop your procedures and update PSI or develop the PSI. If you're installing a new vessel, for example, making sure that all of the codes and standards have been followed and all the process safety information associated with that vessel has been developed and documented. Then you conduct the training. So you train your employees on the procedure, on procedures, SOPs if you have them, MIPs or mechanical integrity inspections and test procedures. All of those things you need to train your employees on. Operations and overall change and how that affects the overall operations. That needs to be done prior to conducting your PSSR. And then and only then do you add chemicals. We don't add chemicals, then do the training. We don't add chemicals and then do the Mlc. We don't add chemicals and then do PSSR. We only add chemicals once we've completed the Mlc, we've completed the PSSR, and all of the training has been conducted. Then, and only then, can we close the Mlc. So what happens when we change existing equipment? And this is always one of the issues that we find a lot of the issues and concerns with when we change existing equipment. So if you go back to the definition within the regulation itself, it just says it has to meet the original design intent. So that doesn't say that, for example, if I put in a vessel has the same MAWP and the same temperature and the same size, et cetera, do I need to do an MOC? Well, not really, but on the other hand, you may want to consider other things that could change when you are changing existing equipment. For example, looking at process safety information. Do you have any PSI that has changed when you make that change to existing equipment? Things like material construction, things like electrical classification, things like design codes and standards. Keep in mind that even when you change a vessel, that original vessel may have been built to ASME Boiler and Pressure Vessel Code Section 8, Addendum M. Well, the new vessel is built to Addendum S or later, so you need to make sure you're documenting those new codes and standards. Maybe the safe limits, and these safe limits, again, are those safe limits not designed in the operating procedure, but designed or outlined in your PSI. Maybe those have changed somewhat. So we need to look at that to determine whether or not you need to do an MOC. Have the operating procedures or will the operating procedures change? Will safe work practices change? We always need to think beyond a document. Think in terms of when we make this change in our process, even though it's existing equipment, is that going to change anything of what we're currently doing? Is it going to change how we do our mechanical integrity inspections and tests, et cetera? And they most of the time, though, there are changes that are involved whenever we change existing equipment, and we need to take that into account. Also, when adding new equipment, we also know that the PSI is going to change. We know that. But what about maximum intended inventory? For example, I know we just came out of a facility that added a new ammonia vessel in their process. Well, they did not update the maximum intended inventory, even though they had to add more ammonia to their system in order to add it to that vessel. So that didn't get changed because they thought, well, the maximum intended inventory stayed the same. But the other thing that occurred is the vessel was larger than any of the other vessels. So by definition, it also changed their risk management plan, or EPA RMP plan. So that needed to be updated as well. So these are sort of things that you have to think through when you're making that change. Maybe your energy load analysis has changed, or your heat and material balance, and you need to look at updating that. Of course, adding new equipment is always going to involve a P&ID change, but also it may change your block flow diagram as well. Equipment specification drawings, all of that needs to be gathered as part of adding that new equipment, including material construction, design codes and standards, etc. The list can go on of when you're adding new equipment. It can touch every element within your process safety information element within PSM. Of course, operating procedure, adding new equipment was going to require new operating procedures. It's always going to include new or mechanical integrity inspection procedures. Spare parts need to be looked at. And then baseline inspections, especially if you're installing equipment in a process like in a midstream process, or a refiner, or a chemical plant. Those baseline inspections need to be gathered. Baseline inspections may be thickness readings. Thickness readings when the vessel is put in service is important to determine your short-term, long-term corrosion rates. Certainly, you can use historical data to do that, and historical data can be from the one that you're actually, or a similar piece of equipment next to it, or it can be based on a similar process that you have. But in any case, establish the baseline readings to establish your corrosion rates and your remaining life before chemicals are added. So other things to consider is in a change is the composition of raw materials. Certainly, this may not affect the processes, for example, like ammonia refrigeration, but other processes, certainly compositions of raw materials change all the time. There's a lot of midstream processes where the composition of the input of the gas coming in changes, and therefore this needs to be considered as part of the change. Process variable or property within an existing system. So if I change the process variable within my process and affects my operating limits, then certainly an MOC needs to be generated, whether that affects the normal operating or the high and the low. We certainly need to update that PSI, and of course that needs to be done through your MOC. About changes to production rates. Certainly if those production rates go above the design of the facility, then certainly there's a management of change that needs to be completed then. Changes to impeller size on a pump. So many times we get in facilities where we ask this question of what the impeller size is in the pump. A lot of times people will not know what that impeller size is. Well, that impeller size can affect a number of things in your process plant. So for example, if I change the impeller size from a 6-inch to a 6.5 inch, yeah, that increases my flow, that increases a number of things, but it also increases my deadhead pressure. So my deadhead pressure now changes. So therefore I may have some downstream relief devices that need to change as well because of the scenario that needs to be looked at in blocked in cases, et cetera. So we need to look beyond just the change and what can affect process safety as a result of that change. How about safety and relief and vent system alterations? For example, I can add another relief valve to a header. That changes the whole dynamics of the header itself and would have to be looked at as part of the change. Also, other things to consider is changes in vessel wall thickness. For example, you take some thickness measurements and that thickness is below the design thickness of the vessel, assuming that it's outside of the corrosion allowance that vessel was provided. If it had was given no corrosion allowance, then certainly an MOC would be should be initiated, and then any fitness for service evaluations conducted to determine whether or not that vessel continue to run in its current state, or if modifications to that process need to be made. Other things is changes to protection or safety systems, and what we're talking about here is normally critical instruments or LEL detectors, ammonia detectors, hazardous gas detection, etc. And any of those changes to those systems, or whether it be in alarms or whether it's on their actual change of the device itself to a different type, all of those would have to be covered under an MOC. How about taking critical devices out of service or temporarily out of service? In other words, bypassing them while you're doing some testing or inspection. And certainly, if you don't have a written procedure for doing that as part of the testing process, then conducting a temporary MOC perhaps is the answer to address that issue. Also, critical equipment safeguards and things in the PHA. If you change any of the safeguards that you have listed in a PHA, for example, then you certainly need to do an MOC, whether that's changing the alarm set point, changing the trigger set point for a shutdown, etc. All of those things would need to be covered through an MOC. How about ITPM, or inspection, testing, preventive maintenance procedure change? Remember, we said the MOC covers anything that is covered in F4 of the standard, or F of the standard. Well, F4 really addresses all those safe work practices, and including ITPM procedures. So if you change a procedure in how you inspect, test, or provide preventive maintenance, then an MOC needs to be done. Again, the MOC helps, again, to ensure that communication is taking place and that training is provided to make sure that they understand what new procedures that you have in place and how to execute that procedure. The other thing is, if you update your PHA, and a lot of facilities don't tend to do this very often, but certainly if you have some recommendations that have been made, then you should go back and update your PHA to show that those items now have been resolved and that risk has been mitigated, and to show that it is complete. So if you do that update, then certainly that should be done as part of an MOC process. The last thing here is organizational changes. So if you're making changes within your organization, especially if they involve process safety, if that person or persons being changed in your organization have process safety roles and responsibilities, then certainly an MOC should be initiated. And oftentimes, the best way to handle this is not only through the MOC, but also handle it through what we call a risk, not a risk matrix, but a RACI. And we talked about this in the first element. We talked about RMP, but all facilities should have a RACI. A RACI is responsible, accountable, consultant, informed type diagram that kind of shows and outlines responsibilities for everything within your organization when it comes to process safety, and who has responsibility in terms of a stakeholder in your facility. So when you do a change in your organization, it makes it much easier to hand that document off to that person that's taking on that new role, so that they understand what their role and responsibilities are and what they need to do. So here's some examples that I always throw out there when I do training on MOC. I always talk about making sure that we understand change, and making sure that we can see the things that could be affected when we make a change. And this is often covered when we talk about replacement in kind. And I give the example of the replacement of a pump. If the pump meets the original design specifications, then theoretically, according to the standard, an MOC would not need to be generated. For example, what if we change the manufacturer's name? It's different. What if the model number is different? and the serial numbers are different. All of this doesn't go to address the design, because the design intent is the same. It's still going to output 250 psig worth of pressure. It's going to still output the 400 GPM, for example, that it was designed. So the original design intent is the same, but all of these items now have changed: the manufacturer, model number, and serial number. So what are the things that we need to consider in this? Obviously, mechanical integrity is one of those. Spare parts is the other. Obviously, you're not going to be able to get the same parts for that pump as you had before that might be set up in your store's spare parts inventory. Those will no longer fit that pump. Also, baseline inspections need to be done. And then quality assurance. Quality assurance is making sure that the pump is installed to the manufacturer's requirements as well. So all of these things would, if we generated the MOC, even in the replacement of a pump, which we would consider replacement in kind, we make sure that all of these things get addressed. And we make sure that the spare parts are replaced. We make sure that it was installed according to the OEM's requirements. We make sure mechanical integrity procedures are in place and they're updated to the requirements of the manufacturer of the pump. May have different requirements than the previous pump that was installed. The other thing is, when do we want to do, or when should we do a formal hazard review or a PHA? Well, certainly these are the items we say every time should require an MOC. If the change introduces a significant source of energy, whether that's chemical, mechanical, thermal, or electrical. If you're increasing your source of energy, then obviously we recommend that a formal PHA be done. If the change can result in an increase in toxic, flammable, reactive material, in other words, you're increasing your maximum intended inventory, a PHA should be done. Change can significantly increase the potential for personnel exposure. So if the change is going to result in increase of that exposure, then by all means, a PHA needs to be completed. If the change takes the process outside the current operating limits, and I want to make sure that that's clear, operating limits. So if the operating limits and you're going to move closer to the safe limits or the limitations of the equipment, by all means, we should be doing a PHA to make sure that we address the hazards associated with that. Moving outside those operating limits means we're closer to the design limits of the equipment, which means that there's a bigger potential for loss of primary containment than there was prior to that change. Also, if the change significantly alters the heat and material balance. So this kind of goes hand in hand with the first one, where you change a significant source of energy, but also it also addresses some of the issues with heat and pressure. If those things increase quite often, it helps to understand that the HMB, especially for those facilities that are not required to do an HMB, then certainly the HMB can use that source to determine whether or not you need to do an PHA or not. Of course, if you introduce new molecules or new chemicals or new materials into your facility, whether they're PSM covered materials or not, then we suggest that you do a MOC. And the reason for that is certainly if you're introducing those new molecules into an existing process, then that process is already covered, then that certainly has altered your process and you need to do that PHA. The other thing is the emergency MOC. So if your policy and procedure allows for emergency MOC, which you certainly can have those, it should be documented in your MOC policy. These are types of changes that can be done without a formal MOC being completed. For example, I need to make a change immediately. I go out there and make the change, and I don't go through the whole formal MOC process until operations resume later on. But certainly I should have contingency plans in place. I don't want to do that in a vacuum. I don't want to do that without addressing the safety and health concerns. We still want to do all of those same things we're just bypassing some of the process steps along the way. We shouldn't be bypassing any process safety steps along the way, however. Some of the things we see that are often missed is changes in metallurgy. So, and this comes down to whether even we hear quite often that stainless is better than carbon steel, so I don't need to do an MOC. Well, that's not always the case. For most of us in the process industry, sometimes stainless steel is worse than carbon steel. So we need to make sure that regardless of what metallurgy is changing, that's always done through an MOC, including the type of metallurgy. You can have stainless steel 304, 316, 304L, 316L, and the list goes on. Any changes within the metallurgy from existing must be done through an MOC. That's going to change a lot of your process safety information as well. The other thing that should be covered in an MOC and included in MOC is rearranging of instruments. So if I rearrange a pressure instrument, for example, from 0 to 500 PSIG to 0 to 400 PSIG, obviously that is significant change, and we need to make sure we're documenting that change. This is something I've seen quite often, you know, in the ammonia refrigeration industry, where the original installation was 0 to 500 PSIA, and they replaced it with 0 to 400 or 0 to 250 PSIA, and then never updated any documents to show that. Also are things like PLC, or programmable logic controllers, and DCS logic changes. Another one that's big, and making sure that we're documenting all of those changes in logic. Especially when it comes to doing a PHA, we need to understand those changes in control and what is actually, and how the process is actually being controlled currently. How about equipment taken out of service? A lot of times we'll go into facility and we do our initial walkthrough. We'll always have somebody say, well, that's out of service, because I'm looking at it kind of intently. And so they'll say, oh, don't worry about that, it's out of service. Then I'll go back in and look at the P&ID, and the P&ID doesn't show it out of service. And of course, the equipment is still attached. The equipment has not been air gapped or anything else. It's still in place. You need to have an MOC to address that. Changes in critical safety alarm set points. So if you have a PHA that says one of your safeguards is an alarm, that now becomes a critical safety alarm. So changing that set point would require an MOC. If it's not a critical safety alarm, then certainly you can change that all day long if you want without an MOC. But if it's a safeguard, then it would require an MOC. Changes in safety control parameter values. For example, let's say that you have an interlock that shuts down a pump when the pressure gets high. That interlock has a trigger set point of let's say 150 PSIG. Changing that to 160 or 140, et cetera, would require an MOC. Again, it's a safety control parameter that needs to be managed. Same way with LEL detection or hazardous gas detection. If you change the alarm to a different value than it was before, one, it should be documented in your SOT what that was. And then two, we want to make sure we're communicating that change to our people to make sure that they understand now what those values are. Here's another one that we see quite often is replacement of valves of different type. And what we mean by that is changing from a quarter turn ball valve to a gate valve, or vice versa, gate valve to a quarter turn ball valve. And there have been lots of incidents that have involved changes in the valve type. Oftentimes, SOPs will indicate open a valve a quarter turn, or open the valve 2 turns, etc. If you change that from a gate valve to a ball valve, obviously a quarter turn on a ball valve means the valve is 100% open when you only intended it to be cracked open. So making sure that MOCs cover any changes in the different types of valves. Obviously, if the valve being changed is a different metallurgy, then that would require an MOC anyway, as we talked about earlier. How about your emergency response program? Changes to roles and responsibilities. Roles and responsibilities may be who does the accounting or accounting of personnel. Maybe those that are on your first responders or responders. If that list is in there and that changes, then obviously that needs to be updated and taken care of through an MOC. And then changes to the plan itself. Maybe the contact information is different and the people who are involved and who does a shutdown in the event of emergency, who stays behind, et cetera. If those changes are being made, that all needs to be covered through an MOC. Remember what I said earlier about the fact that safe work practices, whether that's lockout, tagout, confined space, HAZCOM, et cetera, if those are changed in any way, those changes should be communicated and done through an MOC process. The other things to consider is your risk management programs or your RMP. Maybe your emergency contact has changed. Maybe you've expanded the facility. The largest vessel has changed, or hazardous inventory has increased, or you've had the change in a worst case scenario. All of these things, if you have a good MOC and a robust MOC program and checklist, you'll catch most of these as you're going through the change approval process. So always remember, and really to make your MOC better, we need to track MOC related documentations and action through your PSSR. Remember, if we've got a good, robust MOC program, it's going to translate, hopefully, to a robust PSSR program as well. So there's really a double check of making sure that all of the things that you have agreed to as part of that change are getting done and checked off on when you go through your PSSR. We have to have a method for conducting and documenting training. When it comes to training, so often what we see is operators or maintenance or operations personnel are sent an email, or they're sent a document that says this change has taken place. Do you agree? And what is the operator going to do? Well, they're going to sign off whether they understand it or not. And I will tell you that most of the time they didn't understand. Well, what I'll do as part of my audit, when we do compliance audits, is we interview employees like probably most people would do. But we'll pull some of those MOCs and we'll ask specific questions about the MOC. So most of the time, operators will not have the answers to the questions and basic questions that we are asking about that MOC, mainly because they signed the document that said they understood, but really haven't been providing any verification that they understood the training that they were providing, because they were just asked to check off. A lot of times, people will use the email and automatic replies to indicate that the person understood and was trained on the change. That is certainly not acceptable from a process safety standpoint and making sure that people understand that change. Software and emails, not a substitute for bad policy and procedure. A lot of time people will have software that manages their change and emailed processes to do that as well, but really that's just a bad policy and procedure that needs to be addressed. Always perform reactivity testing for new substances. If you're adding a new substance to your facility, then do reactivity testing. Always review compliance and safety loss prevention requirements. Maybe your facility has those in place, and if they don't, certainly you should develop those policy and procedures as well. Complete a maintenance review and revise spare parts list. There's nothing worse than having a breakdown, no spare parts are available, or two, the wrong spare parts are installed on equipment that was not designed for that part. Can't recall how many times we've seen that one on incident investigations. Always evaluate change against vent relief and flare capabilities. This is often missed, especially when pumps get changed or process changes occur. We don't look at all of the scenarios that have to do with relief. Review existing permits. For example, you may have an operating permit or environmental permits, making sure that those get updated in the process. As you can kind of see when we look at these next steps, really has to do with, again, creating a robust MOC checklist and a PSSR checklist as well. If you have those two things together and they mirror each other, we'll not miss those things when we get ready to add chemicals. Always review the effects on the emergency response. Do you have the personnel that can respond to those new chemicals, for example, or the new process that you're installing? Again, it's always important to obtain required approvals. So nothing worse than having an MOC that has been done, but nobody's approved it. Complete an industrial health or industrial hygiene, safety, all safety reviews. A lot of times when we talk about industrial health, what we're referring to there is making sure that if you're adding a new chemical or adding a chemical to your process, maybe your employees have to be monitored on some frequency to determine whether or not there's any industrial health issues that need to be addressed. Maybe there's noise concerns. You're adding a piece of equipment, now you're no longer below the 85 decibel requirement, so therefore you may have to require a noise and hearing protection in your facility. So making sure you're doing these reviews is important. Complete training on change for affected employees, contractors, and should not be just a sign-in sheet. And you'll see here that I've added contractors to this list to make sure that your contractors, you've got contractors that are coming in and doing work in your facilities, and they're working on a specific piece of equipment, and they've been doing that for a while, then certainly it's important that they get trained on that change as well, or at least have some understanding of that change prior to them coming in the next time. Make sure you change all the appropriate SOPs, and that can be a markup. There's nothing in the PSM standard that says SOPs need to look pretty. So if there's red lines, if you've got some stuff marked out, perfectly fine, as long as they're accurate. That is the key, is making sure your SOPs, just like your P&IDs, PFDs, and plot plans, just make sure that they're accurate. Again, nothing says they need to look pretty, just accurate. I'd much rather have an accurate, a marked up set of P&IDs that are accurate than ones that look pretty or that are inaccurate. Also update process safety information. I can't emphasize this enough to make sure that our PSI is always accurate and current, always, and that we make sure that we're addressing those issues as well. Training is identified and completed, and preventive maintenance and modifications identified, in MIPs created as well, MIPs being your maintenance inspections and PMs, and then spare parts identified and addressed. Also remember, a temporary MOC must be returned to original conditions when completed. Oftentimes what we see when a temporary MOC is expired or is completed, they'll leave behind things like connections to a piece of pipe or connections to a vessel that weren't there before, etc. If those connections are being left behind, then you need to create a permanent MOC to install those to make sure that the P&IDs and all the other documentation is corrected. So don't leave things behind. It needs to be totally the way it was prior to the temporary change, or a permanent MOC generated to address those. More complex changes require a formal hazard evaluation, including a PHA. Always check code standards and internal engineering specifications to determine whether an MOC is necessary. Always complete a pre-startup and safety review, or PSSR. Again, absolutely no addition of chemicals until all the changes are complete. And again, you can use or mark up SOPs, etc., as needed. So I'm going to have a few questions here that I'm going to address, and then if you have any more questions, feel free to put them in the chat or the Q&A, or you can certainly ask me as well. The first question I have: would the 37% of MOCs not being completed be a result of folks thinking it was a replacement of in kind? Oh, absolutely. That is a good question, and And as I tried to point out earlier, that one of the biggest issues we have with MOC is making sure people understand MOC, and more importantly, what is a change, making sure that they understand, like I tried to emphasize today, is that just because it looks the same, smells the same, and tastes the same doesn't mean it is the same. So we need to make sure that we're addressing all of those things outside the box, like is it a model change different? Is there something slightly different? All the spare parts going to be the same? So certainly that goes within that 37%, is making sure people understand what a change is. The next one is, when the change is completed, what is the best practice and how long after the MOC should it be closed? Some folks sometimes drag their feet. Yes, and that's true. We did a compliance audit last week where they had 182 MOCs open from back in 2006 still. So yes, a lot of time people drag their feet, but that's why I say if you connect your MOC to your PSSR, a lot of times it makes it easy. For example, we have our own software application that we use in a lot of facilities for doing MOCs. We require that every MOC has a PSSR. As soon as that PSSR is complete and signed off, it automatically closes the MOC. So we can kind of take care of that whole process in one step. As far as is making sure that that's closed, that's what I recommend that you do as part of that workflow process, that the person that is actually in charge of that MOC also making sure that they're closing the MOC when the work is actually done. Notifications kind of help. If you have a system that provide notifications when that MOC, the PSSR is done, but the MOC is still open, certainly that helps quite a bit. Also having periodic meetings where you address open MOCs with those people that are involved in the MOC. The initiator of the MOC should be also the closer of the MOC. So those are things that might help in addressing that. Next question is, what if just trying a different brand of refrigeration oil for composition of raw materials? Yes, if you're changing refrigeration oils, I would recommend that that is done in an MOC for a number of reasons. First of all, in your oil analysis, and most facilities do oil analysis, it's going to affect the oil analysis itself in what they're actually seeing. If you go to most labs that do analysis of oil, they require you to submit the type of oil that you're using because viscosities and a bunch of other parameters actually change. And you want to be able to look at those. And you want to go back and be able to look if you were to have an incident where you were having compressors, for example, that are failing on some frequency, knowing that that change took effect certainly helps you to find the causal factor and potential causal factors for that increase in reliability, or decrease in reliability, I should say. So yes, absolutely, changing a refrigeration oil, whether it's even changing from one brand to the next, etc., absolutely, I would believe that that needs to be done on an MOC. The next question I have is, is there a way to, I can get you a copy of the presentation? I think that was asked. And what we have the ability, when we get done here, it'll probably take an hour or two. Once we get done with this presentation, it goes into our on-demand file. So I think my staff or somebody on our staff here will actually edit the length of this, take out the ums and the ahs. No, I'm sorry, can't take those out. But certainly we can take out some of the early stuff where we weren't actually doing any recording, and then they'll upload that and be available on demand for you to share with others. Next question is, what is the difference between a minor or major changes? Good question, because I have the slightest idea what the difference between a minor and a major change is. This is something that has floated around in our industry, and I work in all industries. many people will say, well, that's a minor change and this is a major change. And the only thing that they do with a major change is they may do a PHA on it. But there's nothing other than that. Still has to be covered through a management of change. Still has to, depending on what it is, for the most part, still needs to have a PSSR done, especially if that change, whether it's you believe or the person believes it's minor or major, still has to have a PSSR done if there's a change in PSI. So I'm not sure I understand the difference other than the fact that one of them would require a PHA and one would not. I have seen a couple of policies and procedures over the years that try to address a major and minor change. They tried to address that in terms of process safety information, et cetera, and that's just not correct when it comes to the actual requirement for a PSSR. The PSSR is pretty succinct on what is required and when you're required to do one. And one of those things can be a change in a PSI. A simple change in PSI can still require a PSSR. So I'm sorry, I can't answer that one, and it might be up to you and your organizations to develop your policy and procedure to kind of address that. But you know, I have yet to find a good definition of what minor, major really is, because they all can be major or they can all be minor as well, depending on your outlook. I don't know what happened to my screen there, but the next one, IR had taken out major and minor in their written programs. And Deborah, I appreciate you providing that. And that's probably why, is because they probably didn't understand what that meant as well. Okay, I think I'm back now. For some reason or other, I lost my feed. Okay, so are there any more questions that we have? And for those of you who don't know, IAR is International Institute of Ammonia Refrigeration. So for those of you in the refrigeration industry, you know, as was pointed out, is that major and minor was taken out. And I know that there was a discussion, I know I had a discussion with IAR back a number of years ago about that as well, because nobody understood what that was. So I'll give you a few more minutes. If you got more questions, be glad to answer those. Again, as always, you have my email here. Feel free to send me an email, or you can even call me if you want, if you have any questions, anything I can help you with whatsoever. Those of you that I know that have reached out to me over the past 6 or 7 months since we've been doing these, been a joy and a pleasure to be able to help and to make sure that we're all on the same page when it comes to process safety. One of the things that we are going to be talking about probably in the next month or so, I'm putting together the webinar right now. As some of you may have seen, the United States Appeals Court for the 10th Circuit issued a finding or issued an opinion on a case that occurred back in 2014, 2013, and it had to do with PSM coverage, and particular what it means for interconnectivity. And I have a lot of insight into that particular issue. As many of you know, I used to work for 5 years as part of my experiences, 5 years with occupational safety and health or OSHA, and specifically I worked in PSM. Well, that was one of the cases that I was involved with, and this particular case had to do with a boiler that was connected to a fluidized catalytic cracker unit in a refinery, resulted in the incident that was involved, resulted in 2 people being killed, and we cited that, and when I was with OSHA, it was cited for PSM, and that went through all of the courts and made its way to the 10th Circuit, where they affirmed all of those citations, et cetera. And so there's a good discussion about coverage and why interconnectivity is important. Certainly for those of you in the ammonia refrigeration industry, may not be something that you think is important for y'all, but certainly in any other industry, we certainly would love to spend some time talking about it. And I have a webinar coming up where we're going to address that and what it really means and how that case come about. So again, I appreciate you all's time. Again, feel free to contact me if you have any question or if I can help you in with PSM or RMP for that matter in any way. Be glad to help. Y'all have a great day. And if I don't hear from any of you before then, I wish you all a happy Thanksgiving. And again, stay safe. We have to wear a mask. We wear a mask because it's important to keep others safe as well. I appreciate y'all, and we'll see you next time. Thank you.